Hi everyone. Today it's my pleasure to host the 5th session of Azure Fest, broadcasted live from Singapore on a weekly basis. Next week we'll have our last sessions of the seasons, right? Optimizing for multi-tenancy solutions. But today we'll focus on cloud-native applications, architectures with high throughputs. Before moving on, let's remind a few rules, right? So this session is recorded, and you will have a Q&A section where you can ask any question. At the end, we will answer those questions during a 10-minute section for speakers to answer and go through all the questions. And these sessions will be available on a recorded format on demand within 2 to 3 weeks. So today we are focusing on performance and how to achieve very high throughput with cloud-native approach. It's my pleasure to introduce Francesco and Tiamsun Tan, two of our very best cloud solution architects, focusing on app innovations. They help our customers to improve their development velocity, deploy DevSecOps pipelines, and get ready with cloud-native architectures in both private and public sectors. Right? So don't hesitate to reach out to them to continue the conversation on GitHub, Kubernetes, serverless, or API management. Without further ado, Francesco.
Thank you, Francois, for the introduction. So good afternoon, everyone. So my name is Francesco, and I'm a cloud solution architect. And today we will speak about performance optimization of a cloud native architecture. The title of the presentation is based on a customer question that was asked to me a couple of months ago. That is, can cloud native go 20,000 transactions per second? So the answer is definitely can. As you can see from this article from 2017, even at the beginning when we launched Azure Function, it could already scale up to 100,000 events per second. But it's important to remember that there is no one size fits for all solution. So before starting with our customer story, please remember that each architecture, solution, and use case are different. You might need to read you might have an endpoint that just need one row from a database, or you might need to write in 7 different backend systems in Siri. So for each of these scenarios, you might need different type of resource, computational power, and of course, scalability and performance need. In addition, very few people, almost I think nobody, can really, by looking at the architectural diagram, say that this architecture will scale up to 200,000 transactions. You just need 20 core. All of this performance journey is made of a lot of test, assumption, try, fail, improve. So it's a very iterative approach. So you should never expect that there will be a quick solution, but also it's very important to do a lot of tests and keep all your environment always monitored. So today we will cover performance and efficiency, focusing on methodology, then how to perform investigation in a cloud native architecture. It might be similar to a normal setup, but it's important to remind some important tools to use, and then we will share our experience on how to improve it based on a specific customer story that I will explain later. I love solving problems, and this is one of the best part of my job as solution architect. And investigating this kind of issue always remind me the movie Apollo 13. So you will see a couple of reminder and picture from this movie during the presentation. I will start with an introduction of the key component of a cloud native architecture. So I will speak about APIM, Function, and Cosmos DB. Then I will provide the problem statement of our customer, and I will do a journey and how we solve it. At the end, I will summarize our key lesson learned, and we will have time for the Q&A as mentioned by Francois. So let's start speaking about the key component of this cloud native architecture. So APIs are a critical in today's world, and the platform as a service API gateway product of Azure is called API management. This helps customer to securely expose service that are hosted in Azure, but it can also be hosted in other cloud provider or on-prem. This type of service is critical to decouple the external world or also other system or user from all your internal backend service. APIM help to control APIs, accelerate them, observe them, validate that they are properly authorized, and also, of course, help to consume by both internal and external user. It's worth to remind also that there is a APIM provider developer portal that help developer to onboard APIs, and also that if you are using web app or Azure function, you can quickly import the function that you develop inside the APIM in a couple of clicks. So it's very well integrated with other Azure products, and it's very easy to use. The second product is the Azure Function. That is a solution for run a small piece of code in the cloud. You can just write the code and execute it without worrying about the infrastructure that run it. So yeah, this is an example of serverless computing. You can write your code in C#, Java, JavaScript, PowerShell, and Python. And this is a super productive tool. In fact, with also the integration with the CI/CD, in a couple of minutes, you can test a function locally, as we can see in this demo, and then deploy it in production. And thanks to the fact that it's serverless, if you're doing a POC, you might pay just a couple of dollars. And in the moment, and you will pay only per transaction. So you don't need to provision an infrastructure that you will pay every month. So you pay per consumption. And this is one of the most important points about the serverless model. The last component of our architecture is Cosmos DB, that obviously is a database. ESB is a platform as a service solution, and it was built as a cloud native solution. And it's available in all the Azure region. It's a NoSQL database, and you can store information as key value, column family, document, or graph. And those data can be accessed via Core API, MongoDB, and other famous APIs. It's one of the best databases in the world. In fact, it can scale up to 1 million read operations per second, and it's well known to having a very low latency across almost every region. In fact, you can deploy in multiple regions at the same time. So it's this Cosmos DB, you might know it already. In the past, has been very expensive because there were a different pricing model. Now it's also available in serverless and auto-scaling throughput. So it's worth giving a try. All these components together are helpful to have a cloud native architecture for the web. So what we described so far are the three main components to expose an API to a single page web application. And then in addition, you can host all your static content, so HTML, JavaScript, CSS, image, inside the storage blob, and then expose all over the world to a CDN without the need of infrastructure. What is the revolution of this architecture is that if one day you have a very big marketing campaign, or if you have for any reason news and your website start to receive a lot of traffic, since you don't have any infrastructure provisioned and is purely serverless, this can scale as much as you want, and it will automatically manage all the traffic that you are experiencing. All of these are Microsoft's product that easily integrate with Azure Active Directory, so you will be able also to have a good authentication user management mechanism, and also with the CI/CD pipeline, so you can quickly deploy to each of these services in an automated fashion. We are ready to speak about our problem. So a couple of months ago, I received an email saying, Francesco, we have a problem. And as a cloud solution architect working in the customer success unit, I love to design session, but I also enjoy helping customers when they are struggling with a problem. So all of what I'm going to share is a true story. Of course, we will not share the name of the customer, and we try to hide as much as can all the information that might lead to him because, of course, we want to protect his privacy. But of course, we will try to give you the most relevant information to understand what happened and how we help them to troubleshoot this issue. So the key problem of the customer, it was that they were developing a new API involved in a business critical workload. So this API was critical for them to make a revenue. At the peak, during the day, this API was experiencing a peak of request of 20,000 transactions per second. And while testing the new version of the API UIT, they fail to manage more than 4,000 transactions per second. So they had good practice of trying load testing before going live. And the problem was that the load testing was failing and they were not able to go above 4,000 with this expectation of 20,000 transactions. The few remarks on this architecture that were shared with us by the customer was that API management and function app were on premium tier, and the load testing was performed with JMeter, Azure Container Instance, and a Terraform script. Plus, they were already automating the CI/CD using Azure pipelines. Before sharing about our 7-step solution, it's important to mention that all the work that we have done was not just done by me, but it required collaboration of a very extended team of product expert, network expert, developers, performance engineer, architects, and also from Microsoft support. So our journey requires 7 steps. At the initial point, we noticed that we had a lack of information, logs on this architecture, so we had to improve observability. Then after start to gain metrics about the architecture, we start to have the need of be very precise and put in place the right methodology to read logs, perform test. By doing so, we noticed that we had some trouble that we start to see some of the issues that we were experiencing in terms of a request flowing from API-M to the function app. So we assume we had a problem scaling the environment without scaling. So we had an investigation on how the scaling was done. And also the performance testing tool was not able to generate more than 10,000 requests. So we decided to move to Azure Load Test. At that point, we were completely stuck, and that was the moment that we decided to ask for help. And thanks to Microsoft support, we understood that improving the networking architecture was a critical step. And finally, since we were still not able to reach the target number of TPS, we decided to analyze the code. And so looking inside the code was the final step to achieve our objective. So let's start with the first step. So when the customer contacts us, we start to investigate the architecture, and from time to time I will swap to a POC environment that I have. So we went to their API-M, and we noticed that the API-M was not linked to any application insight or there were no diagnostic enabled. And this was very bad because this didn't give us the ability to check logs. So what we have done, it was to check for each of the cloud native service that they were using if they were linked to application insight. And this is a major issue that we see in many customers, that they report to us that they have trouble, but they are not monitoring in production their environment. So the recommendation is to always enable monitoring and app insight in all your service, and try your best to make sure that all the information are going to the same application insight. And this is very important to be able to correlate end-to-end the information. The next step that was critical, it was about being precise. So this is about methodology. The way that an assessment like this one works is that you keep doing tests. So you run one test maybe with 10 nodes where you enable auto-scaling. You try to do a smaller test with 5 nodes and a different configuration. And then over time, you forget about which test you were running and when. So it's very important to put in place a spreadsheet where you will annotate the time, you annotate the configuration of your environment. And this will be critical because when you investigate the issue, you want to know exactly what you were testing. I would like to show you some of the technique then, after that you run a couple of tests, the technique using application insight to debug and gather information from application insight on your cloud native solution. So this is not the same environment that we use for the customer. We had 10 APIM instance, almost 100 instance of function app, and of course I could not share the customer environment. So I try to create a very small POC just to walk you through some of the key component of application insights. When I start to investigate an issue on application insight, it's very important for me. I always go to application map that is here on the left, and then I check the time frame. In this case, I have run a test yesterday in the afternoon. I've done several load testing, and here you can quickly see the three major components of our architecture. So we have an APIM that then is sending 881,000 calls to function app, and function app to manage this load requires spin 7 instances, and then function app is also calling Cosmos DB. So this gives you an initial overview about your architecture and the measure dependency. You can see here that there is a small red dot. So if it is all green, like in this case, all of these requests are successful. If you see red, you might assume that there are some failure. So by clicking on a specific instance, Application Insight will also recommend you where you should focus your attention. So it can give you the top failing request. It can tell you what are the slowest requests. So there are a lot of automation that is done to help you quickly troubleshoot a common issue. As mentioned before, it's very important that you do this at least on a weekly basis on all your production environment. So the next tool that I think is important to mention is the availability tool. Availability is running tests on your environment. So in this case, I have a very basic environment with just 2 APIs, and I decided to test if the APIs work every 5 minutes. Here you can also add your website, for example. And in the moment that it will not return 200, you can configure an alert, so you will be informed if your solution is not online anymore, if there is any issue. So in the specific of our scenario, we were focusing most of our time on this on the performance tab. As I told you before, it's very important to be precise. So the first thing we were doing, it was always pick exactly the same time frame of our test. In this case, I have done a test from 3:15 yesterday to 3:45. And once you specify exactly the range of your test, then you will see all the requests that reach your application insights in that moment. And you will see 2 times a request. You see when it reached the APIM, like this one, and then also when this request is sent, when it's received by the function app, that in this case is the following one. You can have a look also of the distribution of duration that give you additional important information about the different percentile and how much time it takes to execute. So in our specific scenario, what we were experiencing in our architecture, it was that when running a test, we had around 1 million, 2 million requests reaching APIM per test. And then we were noticing that only half of them, so only 500,000, were reaching the function app. And so we were asking ourselves, but where the other requests are going? And so we start to analyze the normal flow of requests, and for this there are very interesting tool where you can see a request by request. You can see the different dependency and the duration. So in this case, you can see how a request reach the APIM, and then after almost 20 milliseconds, it's forwarded and processed by the function app. Then the function app around 10 milliseconds later send contact Cosmos DB, perform an action on the Cosmos DB, and then go back to the function app and go back to the APIM. So this can give you already a good understanding of what is going on, if there is any issue. But in our specific problem, we were not able to really understand what was the problem there. We were experiencing a lot of failure. So we saw that every time that we were performing a test, there were a very high number of failures, similar to gateway error or generic 500 issue, but we were not able to get all the logs. In fact, there is a certain level of logs that are hidden by the platform that cannot be shared with the customer because it might expose implementation detail of our platform. An additional way that we were also using at that time to do investigation was to using logs. So we start to change a little bit the code, and we add some console log to be able to see specific behavior that we were assuming in my cause issue. In a distributed environment like a cloud, it might be challenging try to recollect logs. And the application inside is able to do it for you. So by querying traces inside the logs tab, you will be able to see all your console logs. So in summary, going back to my presentation, we finally were able to see that we had a problem, and the key problem that we experienced was this drop of almost 50% of the request from the APIM to the function app. But we were still not able to understand the key problem. At that time, we made an assumption. Our assumption was that when API management was starting to receive a lot of requests, the function app was not able to scale faster enough to manage all the requests from the APIM. And so we decided to investigate the scalability. When you think about scaling a system, there are two types of scaling. One is the vertical scaling, that is about pick the right SKU, the right RAM, CPU for service. And on the other side, horizontal scaling is thinking about how many instances do you want to spin in the moment that you have an increase or decrease of traffic. The scaling is much related to the traffic pattern. So you might have a lot of different traffic patterns, and this is again one of the reasons why you cannot have one solution that fits for all in this kind of performance exercise. So there are some systems where the traffic pattern is constant during the day, other systems where there is an increase during daytime, and then of course there is a decrease during nighttime. And then in our scenario, it was very uncommon, at least for us. That was almost a constant traffic during the day, but then for just 2 hours a day, there were a spike that was growing super fast of traffic that then was remaining constant, and then it was dropping again. So for this reason, since there were this spike of traffic, we were making this assumption that there might be problem with the auto-scaling. So we start to go product by product. In APIM, we decide to pick the version with the highest number of requests per second that could be managed. And we divide it by the number of transactions, and we understood that we need at least 5 APIM instances. And at that moment, since we were doing an investigation, we decided that we would like to try to remove auto-scaling from the equation and try to manually set the usage of the scaling of all the architecture to the highest number of instances to process this workload. So we decide to just set manually 6 APIM instances before running a test. We made a similar approach to function app, where you have also 3 possible tiers that you can use as for the vertical scaling that are mainly different by the number of Azure computational unit that you can use. So definitely you should pick the one that is not reaching more than 70–80% of consumption of your CPU and memory when in a normal traffic environment. And then you should take care about the right configuration of instances, maximum burst, and also think if you might need about to leverage warm instances. But as mentioned, also in this case, we decide to manually go to set the number of instances. And finally, in the Cosmos DB, the type of computation was quite different. In fact, Cosmos DB is based on the concept of RUs. So every time that you read 1 kilobyte of data, this costs 1 RUs. And so what we have done, it was to test one of our query. You can go inside your Cosmos DB, and inside the Data Explorer, there is the ability to test SQL query. And then when you write a query and you execute it, you will see that in the response, you will get also an estimate of how many RUs it will take to run this query. So what we have done, it was to multiply the cost in RUs of our query by the number of requests. Our query was costing more than 3 RUs, but this give us an idea about how to size the Cosmos DB, how to provision the throughput of our Cosmos DB. So we run all the tests with manual scaling, and unfortunately we noticed that we had exactly the same issue. So we understood from this that it was not a problem of auto scaling, but this became our reference for the sizing of the environment. The fourth step for us, it was to check another issue that we were experiencing. In fact, the architecture used to do load testing was not able to go above 10,000 requests per second. It was failing. It was failing because the JMeter controller of this repository was not able to control more than 10 workers. And each worker have a limited number of virtual users. So we recommend the customer to use a new service that is called Azure Load Testing. That is a platform as a service solution that didn't require the customer to manage any infrastructure underneath, and they could just upload a JMeter file and run automatically the test up to 10,000 nodes using the Azure backend. One of the great advantages of Azure load testing is that it automatically correlates the test with also the consumption and the metrics from server side, and even give you the ability to compare different tests and see how the resources are scaling up, down, and managing the incremental load to the system. So going back to the performance testing, I would like just to make a couple of notes. So if you are running a similar performance testing exercise, it's very important that you understand the maximum number of virtual users you can have per node. In case of Azure load testing, it's 250. But if you're not using solution like this platform as a service solution, you might need to understand the optimal number. You can read specs, but it took some time for us to understand it. And the virtual user are something is similar to, is the equivalent of a human being hitting refresh every time they receive a response. And then another key problem that we face, it was that we need to position the load testing infrastructure very close to our solution. In fact, latency is impacting the number of tests that you can run, because a new test can be run only once you receive a response. So if you have a high latency, every time for each request, you will have to wait more time to get the response, and this will imply that you will have less requests per second. It's very important if your company doesn't have that you think about having a performance testing practice. The key problem for us with our customer, it was that the same developer that was developing the code was asked also to put in place the performance testing environment. And it's not so easy to know all it's a dedicated topic, and they require a lot of time to be very proficient about it. So if you don't have it, most probably try to consider having a team dedicated to run performance testing on all your infrastructure. And just to summarize, at this point, we understood that we had a problem and we were having this million requests reaching APIM, but only 50% were flowing to the function app. We tried to investigate a lot of logs, but we were not able to find any information pointing to a resolution. Then we tried to assume it was an auto-scaling problem, but actually we understood that we had the same problem also with manual scaling. We went to the tab diagnose and solve problems that in some case can be very helpful to find additional issue. This is another artificial intelligence tools that is able to analyze logs and recommend and verify if a known issue were detected. And also the last approach that we tried by ourselves was to read the Microsoft documentation, especially for each of our products, reading the section related to scalability, related to troubleshooting issue, to understand all the limits of this product. Anyway, we were stuck. So we decided to contact Microsoft support. And Microsoft support work by product. So we decided to involve the expert of API management and the expert of function app. It was the right decision to make because Microsoft support can access to additional logs that the customer and also us as solution architect can't access for IP reason. And so they were able to identify the root cause of this issue. That was a SNAT port exhaustion happening between APIM and function app. So the question, what is a SNAT port exhaustion? So this happens when if you are not doing a VNet integration, if you're not using a private endpoint, API management internally, this is hidden from the user, the gateway will use a load balancer will open a port in a load balancer for each connection to external party. The internal load balancer has a limited number of ports that is lower than 10,000. And so in the moment that you exhaust the number of ports of this load balancer, you are not able to create a new one. And the overall APIM is start to hanging there. And so it got stuck and requests start to time out and they are not sent to the function app. So the way to overcome this issue is to use a private endpoint. In fact, a private endpoint has a dedicated IP address that can manage way above 10,000 requests, concurrent requests. Based also on the recommendation of Reza, one of our principal architects, we decided not just to solve the SNAT port exhaustion between APIM and function app, but assuming there might be a similar problem between function app and Cosmos DB, we decided to solve for both the components at the same time. So we end up doing was a better networking architecture where we redeploy APIM and function app inside a VNet. And we expose from Cosmos DB and function app a private endpoint that then was used by function app and API management to connect to their dependent product. By doing this, we encounter a small issue. In fact, if you deploy a VNet in a function app in a VNet and then you create a private endpoint, this service will become private, so nobody can see it from outside, from the internet. And so what happened, it was that Azure pipeline was not able to deploy code to the function app. be able to deploy code to the function app, we had to provision a virtual machine and then install the self-hosted agent that with a specific rule for outgoing connection, it was able to retrieve code from the Azure pipeline and perform all the deployment of code. So at that time, we thought, okay, it's done. We can go home. We can enjoy, dedicate ourselves to a different problem. But actually, we were still not able to reach the expected 20,000 transactions per second. In fact, after the new test, we could reach 10,000, but we still have trouble. And so at that time, we understood that it was critical to look inside the code. And this is something that most probably we should have done it even early. The problem with the code, it was that it was not properly architected. And the implementation had a couple of issues in managing asynchronous call and exception. The main problem was that all these corner cases related to the implementation were not easily to be spotted when just running once or twice the function. It was happening mainly when there were a lot of requests coming, and in case a request was taken to the database, was taking more than usual, the code was getting stuck. So there were a couple of corner case try-catch that was not implemented, that was making the code unstable in a high traffic scenario. So as part of our work as an app innovation solution architect, we help review the code. And so by looking at the code, running it together with the customer, making iterative recommendation, we were able to give several recommendations to unblock the customer. I cannot give you the full list of recommendations we gave to the customer because they're very specific, but my overall recommendation based on experience working on the cloud are, first of all, always profile your code and try to see if the memory is properly used in doing code execution. Always try to avoid any blocking call. In fact, a blocking call anyway might cause a lot of performance issue. And in that case, it's better to consider other type of pattern like CQRS or asynchronous request reply. And then my last recommendation is that it's very important to understand in detail how the SDK are working. And so in some cases, you might have an SDK that allow you to do, instead of 10 requests to a database, you can do a batch request. So you can optimize a lot to the connection, and also the way that you instantiate SDK and the way that you connect to a database. It's very important to use a singleton and be able to reuse across different functions. The key lesson learned on this topic was try to have a look at your code as soon as possible and try to understand if it is really optimized. I would like to quickly summarize the lesson learned. We are almost at the end of this presentation. So optimizing an architecture is a never-ending process. So this presentation covers some of the problem solving and methodology required to improve performance in cloud-native architecture. But in your case, you might need to solve a completely different set of issues. So be successful is definitely a matter of team working, because you might not know all the answer and also all the area you should explore, proper process and methodology, problem solving, and of course a bit of creativity, especially on the coding part. So as a final summary, it's really important that you make sure your architecture is fully observable, and the application insight is a must-have tools, and it should always be enabled in every service you deploy. And make sure that or you have a process to analyze the logs weekly, or you define a lot of alerts to make sure that if something is failing, you get notified. The second point is performance testing is a matter of process and precision, and you should consider to have a dedicated team for it. This will help you a lot to quickly understand the behavior of your architecture when scaling. The third point is that troubleshooting an issue is not a job for a lonely wolf. So when needed, you should ask for help. We are here to help you. And also the fourth point is that your source code quality will be the most tedious bottleneck most of the time. And so if you should really spend a lot of time to optimize your code, profile it, understand what is going on, and definitely throwing resources, so buying more computational power is not the answer. So if you notice that there are problems in executing your code, don't just scale up your resources. Try really to understand what's going on, because throwing a resource might be the solution when you have 5,000 requests, but then if you need to scale maybe to 50,000 requests, you will not be able to manage just by scaling up your environment. And finally, leverage as much as you can on Microsoft documentation, and check the well-architected framework. In fact, they give you a lot of interesting checklists of item pattern that you can validate and review before going live, or even when you have a live environment if you want to improve it. Yeah, this was the final architecture, and I would say that for now, yeah, the presentation is completed. Happy to answer to any question that you might have.
Thank you, Francesco.
Thank you.
Maybe we can proceed to the Q&A section. Then there was a first question on a checklist for performance specifically, right? And there was a first answer, but maybe you have more.
I think as a checklist for performance, there is a very interesting checklist in the well-architected framework, where you can find a lot of different areas. And I really recommend you to read. There are, I think, 10, 15 patterns that you can read. For example, how to apply a cache, how to apply a synchronous pattern that can make the difference when trying to improve performance.
Sure, thanks. And then there are different questions on different level of the architecture itself. Maybe I go through them. Is how do I configure a storage account to serve web pages? I guess it's on static web page, but I go on similarly on web app. Is there a best practice on overall architecture on web app? And finally, for the database, a question on what is the best approach, right? Whether one database per customers, put everything into one DB, and how we handle that, right? So static page, web app in general, and finally database.
For the static page, I think there is a resource. Yeah, I think Tiamsun already shared it, and this is a guide that helps you to configure in the proper way a storage container, a blob container to be exposed over internet. You can directly expose a blob storage, or you can also use a CDN to make it faster. The second question, I think
it's for
missed it.
What is the recommendation for web app in general? I think there is no specific like static or.
So for me, the recommendation for web app is try to leverage as much as possible this type of architecture, especially if you have done custom development with API. If it is a super simple use case, you can consider to use a static web app that I tested myself with React, and the static web app also give you the ability to spin some function app and use your custom domain, scale infinitively, and the price is for just 2 websites is I think is $0. So it's a super good offering to host I would say small medium web solution completely based on JavaScript. If you have a more complex solution, I recommend you to give a try to this architecture, and definitely you will see good improvement in terms of scalability and costing. And the last question I think was on database.
Yes, what is the recommendation on should we have everything into one DB or segregate by DBs? I mean, what is or any sharding or anything around that?
This question is quite too open. It will depend also on how many requests you are performing to the database. So sometimes you need to do sharding, or you need to split a database because also because of the different access pattern that you might have. And also other time is by regulatory reason that you need to split database by customer. So there are, again, if it is a super small solution with not many data residency regulatory issue, I will always start with one database and then break it down following criteria like performance improvement or segregation. But again, I think also in this side, the well-architected framework can help to, based on your need, to understand what could be the right pattern.
Thanks for calling out the regulation, because that's something whereby sometimes we overlook, right? We put everything in one DB, and then when we need to start segregating based on data residency, that becomes a challenge. But for performance focused, usually one approach is also to look at having replicas for read, right? When typically we have a read intensive application, don't hesitate to scale more read replicas while you don't have the overhead of managing multiple databases, because automatically it's managed.
Yeah, I didn't think from a performance point of view, and yes, and that's when the CQRS pattern that I mentioned became very important. In fact, you might, in a scenario where you have a master node and then read the replicas use to speed up, to have multiple, to increase the throughput of the overall solution. In that scenario, it's very important that you split between read endpoint and write endpoint, and all the write that you perform can't be performed in a synchronous way. So you will need to develop a command that will perform operation synchronously. Of course, to do it, there is an impact also for the customer. When a user-facing endpoint develop synchronously or asynchronously as a different customer experience. But sometimes there are trade-offs that you should make in terms of customer experience to ensure that then your system is performant.
One more question, which was added, I read it. Is importing custom libraries into function affecting its performance? Example, a big library, like 30 to 50 megabytes, is not built into functions. How to bypass this bottleneck, if it is?
A good question. So most probably in a scenario, it will really depends. So on the scenario, I have I've been using a lot of very heavy library in couple of projects, and I didn't see a major issue on the performance. If you make sure that it's loaded only once, so this library will be loaded and shared every time that you create a new instance. So only when you scale to a new instance, you will need to wait a little bit more of time to load it in the memory. And then it's a reuse. So based on my experience, 40, 50 megabytes should not be a big deal. You can always think about trying to see if you can optimize this library, but definitely you might need with the 40, 50, you might need to have you might need to scale up a bit your function. Again, I would say try to test based on my understanding. If you are then you use it in the proper way and you ensure that you have singleton and you reuse this library, I don't think it will impact too much your performance. Happy to take this offline with all the details, and if you want to send me an email.
Maybe one question from my end, then I think we covered the question asked in the Q&A. It would be, what are your recommendations to integrate load testing into my CI/CD pipelines, right? Should I be like any deployment? I mean, how can I do that so that I have this ongoing pace of understanding if there are any regression and so on?
Okay, so it's so in Azure DevOps, I'm not really recommending. So you can do load testing, You can also automate, so there might be one, you can configure it to trigger it via an API call, load testing, but I will not do it in a normal CI/CD process. What I will do doing continuous deployment is after that I deploy a service in Azure DevOps, I will use a post-deployment gate that you can configure to ping the environment where you just deploy to validate that the service is on. You can also test the send specific request with header JSON and also test the response. So in this way, you can, every time you deploy, you can run, you can also decide to run a couple of tests every 5 minutes and validate that your environment is working. What I also do most of the time in my DevSecOps pipeline is to add also a penetration testing. So you can configure, you have a container and you can tell the container to target a couple of APIs and validate that your endpoints are secure. But then I will most probably do performance testing as part of a dedicated pipeline that I decide to run only in specific scenario. At least this test require a lot of minutes. Otherwise, you might block your entire CI/CD to do it.
Got it. Thanks a lot. I think we are on time, folks. I mean, we want to hear your feedback. So please, by any means, post your feedback. Tell us what you like, what you would like to see in the next sessions as well, what we can improve. Thank you very much for joining today, and have a very, very good day.